Hi there. We're completing the cool down and lesson for 7.43. This is where we are revisiting what we've done with proportional relationships. So, in the first slide that you had to complete, we're given a recipe and we have to fill out the missing pieces of this table. Now, we did a lot of work with filling in missing pieces of tables in Unit 2. And basically, we're looking at ratios. So in this particular one, the ratio is 1/2 cup of sugar for every 1 cup of flour that's used. So these are going to be finding different ratios for different batches of this recipe. So there's a couple ways we can look at this. We could look at this as a ratio. So we know that for every 1/2 cup of sugar, there is 1 cup of flour. Okay. We could also draw some pictures. So we know that if there is for every 1 cup of flour, so I'm going to make this whole bar be the flour, and that is 1 cup. Whoops, that's not very good. So this stands for 1 cup of flour. We know that this 1 cup of flour is actually made up of 1/2 a cup of sugar. Okay, so there's lots of different ways we could think of this. When I'm looking through here, I kind of see that I know that 3/4. So we have to figure out 3/4 cups of sugar is how many cups of flour? Well, I happen to know that 3/4 is the same thing as 1/2 plus 2/4, or I'm sorry, 1/2 plus 1/4. And I know this because 1/2 is also 2/4, right? So I know that those are equal fractions. And I'm actually going to use this idea to help me figure out the amount of flour. So when I see this, I know I'm going to take that this part, the 1/2 cup of flour, requires, or I'm sorry, 1/2 cup of sugar requires 1 cup of flour. And I know that from the recipe. So 1/2 means 1 cup of flour. Okay. So 1 cup. Whoops, there we go. And then I also know, okay, well, 1/4 is actually half of a half. So if this is half the amount of sugar, then I'm going to also use half the amount of flour. So I know 1/4 cup of sugar requires 1/2 cup of flour. And so if I was trying to figure out here the 3/4 cups of sugar, I know that's going to end up being 1.5 cups of flour. So I could write that in. I could do 1 and then 1/2. And notice it turned green, so I got it correct. Now, I'm also going to skip down to this next one here, this one. So I'm going to skip this guy. I'm going to go to this one. For this one, I can look at this and think of it as I have 1 cup of sugar. Well, I know that 1 cup of sugar is actually twice the amount as 1/2. So if I'm doubling my amount of sugar, I have to double my amount of flour. So I actually know that that is going to be 2. So now when I come down to these last two, I basically need to try to figure out, is there a pattern happening here? And I don't know if you all noticed, but I noticed, especially when I got down to this, I knew, oh, look, if I want to find the amount of flour based on the amount of sugar, all I do is multiply my sugar by 2. Because 1 times 2 is 2. Ugh. And also up here, I know 1/2. If I double 1/2 or do times 2, I get 1 Okay. So, and actually look, 3/4 times 2, I actually get 1.5. So that's great and all, but now I'm going backwards, right? So I can also notice the pattern that if I want to get from flour to sugar, I'm actually going to cut it in half. So 1, if I cut it in half, that's the same as dividing it by 2. So if I divide 1 by 2, I get 1/2. So if I want to get, okay, well, how much sugar goes with this flour? If I cut it in half or divide it by 2, that's going to give me my answer for here. And that'll work for this as well. If I divide it by 2. So I can actually use my calculator, and I know I'm going to be doing 1 and then 3/4. So I did my 1. This will make my next thing a fraction. So I'm going to do 1 and 3/4 divided by 2. Whoops. And I'm looking at this and this isn't quite right because I'm seeing that it's saying not what I want. So let's see if I can get this. All right. I'm actually just going to hit enter here and see if I can get, okay. Fraction. I wanted a decimal. Okay, so I was having a problem with getting my calculator to do what I was telling it to do. So here's what I need to do. I'm going to go ahead and do 1 and 3/4 again. 3/4. Now, if I keep going, it's going to think that whatever I'm doing is going to happen to this denominator of 4. So I'm actually going to click on the over button, and that's going to take me to what I want to do next. And now I'm going to do divided by 2. And when I do that, I get 0.875. So let's try that out. And good, it turned correct. And now I just have to do the same thing here. You can put it in the calculator, or I'm going to do this in my head because I know if I'm going to take 2.5 and divide it by 2, I have to divide my 2 by 2, which I know is 1. And I have to divide 1/2 in half. And I know half of a half is 1/4. And I did also get that correct. All right, great. So now we've kind of looked at some different ways that we can fill in this table. So let's take a look at the problems because these are really the kind of problems that you're going to have to be able to solve. Okay, Tyler's dribbling a basketball at a constant speed of 5 meters for every 4 seconds. How long does it take him to dribble 114 meters? And when I look over here, I've noticed they've already created a table for me and they've put all this information into the table. So we just have to figure out what goes here. Now, I'm going to be using the idea of constant of proportionality. And this goes back to what we did in Unit 2. In Unit 2, we learned that if this table is proportional, that we're always going to be able to multiply 5, and in this case 114, by the same number. And the number is going to be the distance. We're going to be multiplying it by what we called the COP. Whoops. And the COP is the constant of proportionality. We also learned that in order to find the COP, it's basically figuring out, well, how long does it take Tyler to dribble 1 meter? So it's like saying in 1 meter, how long? This will be the COP. Okay. And the way we find that is we're actually going to take, we're going to look at this, and I'm actually going to draw it out first, and then I'll show you kind of a shortcut. So we know that in 4 seconds, so I'm going to draw out, this is called a bar model or perhaps a tape diagram. In 4 seconds, I'm going to write this in, 4 seconds. This whole box is worth 4 seconds. And what I'm going to do is I'm going to divide it into the amount of meters that Tyler was able to travel in 4 seconds. So I know he went 5 meters. So what I'm going to do is I'm going to divide this up into 5 equal-ish pieces. They should be equal, but I'm doing my best. So I've got 5 pieces, and each one of these is going to represent 1 meter, right? And remember what I said, we're going to figure out what the COP is, or the constant of proportionality. And the constant of proportionality is this unit rate here. How long does it take him to travel for one of these meters? So we're basically trying to figure out how many seconds is this much going to be if this whole entire thing is worth 4 seconds. So you might already see the division problem here. We've got 4 seconds, right? And we want to know what this one piece is. So we're actually taking that 4 and we're dividing it. It's being divided into 5 equal pieces. So when I take the 4 seconds and I divide it by 5, and you've got to make sure you do it properly in your calculator. It's 4 divided by 5, not 5 divided by 4. So 4 divided by 5 is actually 0.8. So I know that, I'm going to erase this so I have room. I know that for every meter that Tyler is dribbling, it takes him 0.8 of a second to go that far. So this is 0.8. So now I actually know that 5, if I have 5 0.8, because each one of these is worth 0.8, right? So this is 0.8 seconds. Every meter is worth 0.8. So 5 times 0.8 gives us 4. We just proved that. And if I want to know how long it takes him to go 114 meters, I'm also going to multiply by the COP of 0.8. So when I do that, I'm going to take 0.8 or 0.8, whoops, I need to clear that out, don't I? 0.8 times 114. Now, there's different ways to know that that is times 114. One is that we figured the COP is 0.8. The other way is to know if I have 114 meters, or these boxes, I need 114 of 0.8. And we found that that is equal to 91.2 seconds. So we're going to have to type that in. All right, and there we go. So we used the COP to figure out this missing piece, right? So let's look at this next problem. This is working in the same way as what we just did, except we have a table, but we didn't put, it doesn't have any of this information in it. So if I want to solve this, we're going to put our information from the problem into the table. So let's see, a factory produces 3 bottles of sparkling water for every 8 bottles of plain water. How many bottles of sparkling water does the company make or produce when it makes 800 or 600 bottles of plain water? Okay. So I'm going to go from this original piece here where it tells me for every 3 bottles of sparkling water, they make 8 bottles of plain water. And I'm just going to plug that into my table. So 8 bottles of plain water, they make 3 bottles of sparkling water. Now, the question says how many bottles of sparkling water? So we're going to try to figure out this. We don't know the answer to this. How much sparkling water do they make when they make 600? Whoops, that's a 0. 600 bottles of plain water. So this is going to work out the exact same way as my previous problem did. We figured out what the COP was first, and then we used that COP to get the empty unknown value. So over here, just to kind of remind you from Unit 2, we also were labeling our columns of tables like this with an X and a Y. And we used that when we started graphing them and when we put these into equations. So we're going to continue doing that. And remember, we're trying to figure out what do we multiply x by? So what the x times the COP equals the y, okay? So another way to look at this is if you ever want to find the COP or constant of proportionality, we find the constant of proportionality by doing whatever the y value is divided by x, okay? Or I'm going to rewrite it, y divided by x. So taking a look at this, remember, we're trying to figure out what do we multiply 8 by? What's the COP that we multiply 8 by? So that we can also use that COP to multiply the 6 by, and that's going to give us this. So in order to solve, we take our y value. So we're going to take the 3 bottles of sparkling water. I'm going to actually use a different color. We're going to divide that by our x value. So the 3 goes with the 8. So we're going to divide 3 by 8. So let's see here. 3 divided by 8 gives me 0.375. Okay, so we know that we're always going to be multiplying by our constant of proportionality, which is 0.375. So to find my answer, we're going to do that. Okay. So I'm going to take 0.375 times 600, and I get 225. So let's check that out and see if that makes sense. All right, great. We got that one right. So again, we did this because we were able to find the constant of proportionality. When we're solving these problems, our main goal is figure out what are we multiplying this column by to get the second column over here. And we use the division to figure it out. Okay, the third question, this is basically where we're achieving our objective. Our objective for today was to be able to solve a problem like this using a table, even when they don't give us a table. So we're going to make a table to answer this question, okay? And then we're going to solve it exactly like we have been. So for this one, somebody's mixing paint. And to make the paint, it's saying that they're mixing 1.5 quarts of blue paint, all right? So they're going to do 1.5 quarts of blue to every 5 quarts. I'm just rewriting this as a ratio, right? So we have to figure out then, if that's the case, how much white paint, so I know that this is blue paint to white paint, and then they're saying how much white paint do we need to mix with 4 quarts of blue paint. So they're saying if we have 4 quarts of blue, how much white do we need? So we don't know, okay? And we're going to use this table to solve it. So the first thing I need to do is decide, well, I've got blue paint and I got white paint, right? And they're in ratio. So I'm actually going to set my table up a lot like this. We're going to make this is usually remember we call this our X value. So this is going to represent the amount of blue. And then our Y value over here is going to be how much white we mix with that blue paint to get our light blue. Okay. And again, we're going to take the information from the question. So they're saying we need 1.5 quarts of blue for every 5 quarts of white. So we know the 1.5 of blue goes with 5 quarts of white. Okay. And then they said, again, I'm going to make it look just like this. The blue is on the left, like it is on our ratio here. So then they're saying if we have 4 quarts of blue paint. How much white paint do we need? And again, we're going to find the COP. What are we multiplying? There's a relationship here because it's proportional. So what do we multiply our blue paint by to get our white paint? So the COP is, remember, to get that, we do Y divided by X. So we're going to start with the column that actually gives us the information. So over here, here's our information, right? So if we want to know what we're multiplying 1.5 by, we're going to have to divide 5 by 1.5. And that's going to tell me what my COP is. So again, I'm going to go into here. I'm going to do 5 divided by 1 fraction and a half. Okay, and I'm getting this. Now, this is a messy decimal because it never ends. And because of that, we're actually going to write this. The best way to write this is as a fraction. So I just hit that button and it converts my answer back and forth. Decimal fraction, decimal fraction. So I'm doing this again because this is exactly how much the answer to this equals. And notice this, my answer should be in a fraction or mixed number anyway. So we're just going to use 10/3. So if we have 10/3 as our COP, that means if we multiplied 1.5 by 10/3, we've got to multiply 4 by 10/3. And so if I come back here, we're going to do 10/3. I just hit answer and it copied my answer. And we're going to multiply it by 4. And again, I get a fraction. I get a weird decimal. I can click this to get a fraction of 40/3, which if I simplify this, it actually is going to be 13 wholes. So I'm actually going to write 13. And then I know that this is 1/3. But you could write 40/3 and still be okay. So I'm going to write 13 and 1/3 as my answer. And I'm going to show you, if I were to put in that decimal, it doesn't count it correct because this isn't technically right because these 3's go forever. But if I write 13, and 1/3, there we go. We get that right. Or you could have written 40/3 and it's still right. Okay. So this, like I said, is exactly how we would solve these problems. Or is what you're supposed to be able to do by the end of this lesson. I'm not going to tell you how to do the rest of these. This we're skipping for right now. This was more for an in-class thing. If you want to try it out, try it, but you don't have to. So we're skipping slide 6. Slide 7, you are going to have to write in here, synthesize. Think about this. How did we use the table to solve a problem about the proportional relationship? There were 2 steps, right? Think about what we did first. We found the COP, and then we multiplied the COP, the constant proportionality, right, by this X value to get the Y value. I'm also going to show you in your Google Classroom, if you go to the Anchor Charts and Videos, this is going to be helpful because we're reviewing a lot of things from Unit 2. So the place to go for this one is this, using tables to find a constant of proportionality. This chart is going to help you out. It actually gives you the steps. So it's telling you we're going to find our COP by dividing Y divided by X, and then we multiply what our X value by that COP. Now, this slide is just reviewing our objectives. And then this final slide, I want you to solve on your own. So you're going to have to make a table out of the information here to solve for how much do 7.5, and by the way, LBS just means pounds. It's an abbreviation for pounds. So if this is true, that $3.45 will get you 3/4 a pound of chopped walnuts, how much is 7.5 pounds of walnuts going to cost? So this will be your cool down. And once you've typed in all these answers and done your best, you will get credit for this assignment. So thank you.